So the first thing you're going to do on your page in front of you is to draw a large, very clear diagram of the situation. I'm going to go to the next slide because I've started to do that already. And as you'll see, I've started by drawing the vector that represents the plane traveling due west. That's 2,350 kilometers. The yellow dotted lines represent a little compass bearing that will help us with our direction. Notice that I've placed the vectors head to tail. Now, it doesn't matter which vector comes first. Your resultant will still be the same. I just like to draw them in the order that's given in the question. So the plane first heads west, and then it heads north 32 degrees west. So notice how I've drawn that direction from the head of vector 1, and I'll write V1 here and V2 over here. I drew the yellow dotted line for the compass so that I can get my appropriate bearing for vector 2. 32 degrees is drawn from the yellow dotted line, not from vector 1. Right? And that's important because when we use cosine law to solve, our angle has to be correct. So the question is, what is the resultant displacement? Or in other words, where is this plane actually going to be headed after it changes its direction slightly? So the resultant vector will be the vector that's drawn from the tail of the first vector, which I can show you by drawing a vector in another color. Let's use red. I'm going to start the vector from the tail of vector 1, and it has to reach the head of vector 2. So that's going to be my resultant vector. I'm just going to add vector headings on it there. And I'm going to always denote my resultant vector with r. So I want to know the direction of that vector and the magnitude. Let's start with the magnitude. In order to get r, we're going to use cosine law. Now cosine law needs an angle between the two given vectors. Now I'm going to highlight that angle here. That's the angle that you need. So what is that angle? Let's draw a little arrow here. Well, I know that this is 90 degrees. I know that was 32 degrees. So if we add 90 and 32, we get a total of 122 degrees. Now we can use cosine law because we have a side angle side conjunction. So I'm just going to go to a next slide and start the calculations clearly. So the magnitude of vector r squared is going to equal the magnitudes of the other vectors squared minus 2 times both of those magnitudes, and 1560 times the cos of 122. So do the calculations, you end up with a large number for which you have to take the square root, because remember, cosine law has that magnitude squared. So you can't forget to take that square root. When you do that, okay, the resultant vector has a magnitude of 3,441 and 0.14 kilometers. So that's the total displacement of this airplane, or in other words, how far it's traveled. But now we need a direction. So I'm going to go back to my diagram, and for the direction, let's use a different color. I'm going to use bright green. The direction has to be given from the starting point here, which means we're looking for this angle in green. I'm going to label that theta. So you need to solve for theta. The best way to do that is to use sine law. And we have enough information to do so because we have an opposite side pair. So to solve for theta, I'm going to set up a sine law. Sine theta over 1,560 is equal to, now I'm going to use the opposite side pair for the angle that we found of 122, all over the magnitude of r, which we just solved for. It's about 3,441.14. Now you're going to solve for theta. When you do that, you get about 22.9 0.6 degrees. So now we can give a direction for our resultant vector. We can state, go back to red, that the displacement of the airplane is 3,441.14 kilometers. Now we're going to give our direction relative to the starting point. So that is going to be west, and if we just flip back for a second, west 22.6 degrees north, because again we're looking at it relative to the west direction. You could do an extra step and get the supplementary angle, but there's no need to. This is a perfectly good final answer. We have a direction. We can finish off by saying from the starting point. And that is a full solution for question 1.